This video is for class 9 physics, and in this video we are discussing about relative density. The word relative here means in relation with, right, with the density of what, right? So actually here they have written Rd equals to rho s upon rho w, which is the density of a substance upon the density of water. So here what we are doing is relative density is the comparison between two densities, right? That can be again derived to ms upon mw for the same volume, right? For the same volume, that means both the masses should be for the same volume. We have read that the density of water at 4 degrees Celsius is 1 gram per centimeter cube or 1000 kilogram per meter cube. Treating it as a standard, the density of substance can be compared with the density of water at 4 degrees Celsius. Can be compared. Now, why to compare? Right? The question will be why to compare. Right? So it can be compared with anything, but why only to compare with the density of water at 4 degrees Celsius? And the ratio so obtained is termed as the relative density of the substance. Now, we already had density of the substance, right, is equal to the mass of the substance upon the volume of the substance. So if we know the density and can be derived out from the formula m upon v, why to study this relative density, right? What's the use of comparison here? The reason is, if you can see here, relative density ultimately comes as ms, that is the mass of a substance upon the mass of the water. So here the volume is not needed, right? Volume is not required. So since it is not required, so my work becomes easy. So if I take this here only density, so what do I need to do is I need to take out the mass first, then I need to derive the volume, then only I can take out the density. But here the relative density, right, can be taken out just by knowing their masses, the mass of water and the mass of the substance, right? So now my work has been decreased, okay, if I know relative density. But we have to know how to convert this relative density into density also. Let us do that afterwards. Now let us go to the definition of relative density. The relative density Rd of a substance is the ratio of the density of that substance to the density of water at 4 degrees Celsius, right? So it is just a comparison. So here relative density is the ratio or comparison between the density of substance, which is rho s, upon the density of water at 4 degrees Celsius. Why 4 degrees Celsius? Because the standard value at 4 degrees Celsius will be 1 gram per centimeter cube, right? If I take the value 1, it will be easier for me to calculate, right? Now, as you all know, the definition of density, which is mass per unit volume or mass of unit volume. So here they have written the definition, okay? This rho s and rho w has a definition, they have written it here. So mass of unit volume of substance upon the mass of unit volume of water at 4 degrees Celsius. Here you can see the unit volume and the unit volume are same, right? So this unit volume and unit volume can be cancelled out. Now the new expression will be mass of a substance ms upon the mass of equal volume of water at 4 degrees Celsius. They can only be cancelled if they are equal. In this case I am cancelling because they are unit and unit, but they might not be unit, right? They can be any volume if I just consider the density of substance and density of the water. Now to cancel that volume, the volume of the substance and the volume of the water should be same. Therefore they have written mass of an equal volume of water at 4 degrees Celsius. So my formula has become ms upon mw. Let that be equation 5.6 as shown here, right? Equation 5.6. Thus here 5.6, thus the relative density of a substance is also defined as the ratio of the mass of substance to the mass of an equal volume of water at 4 degrees Celsius. So we have two definitions, you can use any one of them. Unit of relative density, since the relative density is a pure ratio, either it is rho s upon rho w or it is ms upon mw. In both the cases the units will get cancelled, therefore it doesn't have any unit, and it is a scalar quantity because density is a scalar quantity. So this relative density also becomes a scalar quantity. Now, relationship between density and relative density. When we started the topic relative density, I said that it becomes easier for us to derive density, but without knowing the relationship between the density and the relative density, it is worthless. So relationship between density and relative density will be, while calculating the relative density of a substance from its density or density from its relative density, we know that number one, in the CGS system, density of water at 4 degrees Celsius is 1 gram per centimeter cube, right? 1 gram per centimeter cube. So the relative density of a substance is equal to the numerical value of the density of a substance. Thus, the relative density will be equal to the density of substance in gram per centimeter cube upon 1 gram per centimeter cube, right? So the density in gram per centimeter cube will be equal to the relative density. We'll understand with an example here. The density of a copper is 8.9 gram per centimeter cube, so its relative density will be only 8.9. Simply you take this unit out. So if there is no unit here, gram per centimeter cube, only this 8.9, if we are writing it, it becomes the relative density. Or if the density of mercury is 13.6, okay, here this we have to discuss. Or if the relative density given to us, suppose the relative density given to us is 7.8, right? Okay, so the density will be, so the density dnsity, so the density will be 7.8 gram per centimeter cube, will be 7.8 gram per centimeter cube, right? This is how we need to convert. Now going to the next part, that's number 2. In SI system, the density of water at 4 degrees Celsius is 1000 kilogram per meter cube. So its relative density is relative density will be equal to the density of substance in kilogram per meter cube upon 1000 kilogram per meter cube. So density in kilogram per meter cube will be relative density multiplied by 1000. Relative density multiplied by 1000. Let us go to the second example here. Example number 2. The density of mercury given to us is 13.6 into 10 to the power 3 kilogram per meter cube. Hence, its relative density will be 13.6 only. No 1000 will be included here. Okay. Or if the relative density given to us is suppose 8.9, then in the SI system, the relative density will be equal to 8.9 multiplied by 10 to the power 3 kilogram per meter cube, right? Kilogram per meter cube. So the relative density of silver is 10.8. Its density in CGS system will be 10.8 gram per centimeter cube, and in the SI system it shall be 10.8 into 10 to the power 3 kilogram per meter cube. Let us go to the differences between the density and relative density. So differences between, or the difference between density and relative density. There are 2 points. These are very easy. A density will be equal to density of substance is the mass per unit volume of that substance. This is the definition of density. In point number 1, relative density will be equal to the ratio of the density of that substance to the density of water at 4 degree Celsius. Number 2, it is expressed in gram per centimeter cube or kilogram per meter cube, whereas relative density doesn't have any unit. These are the 2 differences between density and relative density.